The MEP Objects Parametric Configurator. The accessories, equipment, and terminals available in Edificius MEP are simple model entities that can be customized based on their geometric and technical parameters. These are defined as Parametric MEP objects. These entities are activated from the drawing menu and are modeled using the Parametric MEP Objects Configurator, a tool that allows the user to customize models. If you activate one of these entities from the drawing menu, for example, pressurized accessory, like the other MEP objects, one of the accessories present in the default library is activated in the Properties toolbox, the title of which is shown in the tooltip that appears in correspondence with the Model field. By clicking on the Model field, the three buttons appear with functions similar to those seen in the case of pipes and fittings, although differences can be seen for both the plus button for adding a new MEP object, and for the project library editor. By clicking on the plus button, a menu appears that allows you to choose between three modes for generating the MEP object. The first button, with the gear symbol, allows you to create the MEP object by choosing the model from those present in the software library. The second button allows you to generate an MEP object using a 3D model imported from a file. The third button, illustrated with the magic wand, generates an MEP object using a 3D model inserted in the architectural environment as a model. By clicking on the first button, the Parametric Configurator of the MEP object opens, which allows you to create the model in 2 steps. At the first step, in the box that appears, on the left is the list of categories of the selected entity contained in the program library. By selecting one of the categories, the types list for objects belonging to it appears in the right pane, for which the name and object preview is also shown. Let's suppose that the manifolds category and the cast monoblock coplanar manifold types are selected. Clicking on the next step allows you to jump to step 2 of 2, although you can cancel the modeling process and go back to the previous step at any time. In this phase, a 3D environment is shown in the box on the left, showing the preview of the model accompanied by labels indicating the positions of the connectors. Being a 3D environment, you can orbit using the right mouse button or you can use the zoom to view the details. The category and type of the selected object are specified at the top right, while the object type box shows all the available models, classified on one or more characteristics, depending on the type of object selected. In the case of the cast monoblock coplanar manifold, the parameters that define the model are the nominal diameter of the inlet-outlet connections and the nominal diameter of the branched sections. In particular, in this case, for the same value of the nominal diameter inlet and outlet there are 2 models which differ from each other in the male or female type of the connection for the derivation. When a model is selected, for example, the one characterized by a DN25 for the inlet-outlet and a male connector type for the derivation, to which a DN20 is associated, both the preview of the 3D model and the technical and geometric parameters are dynamically updated shown in the box below Object Properties. In this last box, it's possible to customize the model both from a technical and geometric point of view, assigning different values to those set by default and related to the chosen model. Proceeding in this way it's possible to create multiple 3D models, starting from the basic ones and assigning them different and customized values relating to the parameters that define the geometric properties of the object. The technical parameters do not affect the 3D model, however, they can still be assigned to classify the object and to be able to use them eventually in a subsequent phase of the design or the preparation of the metric calculation. Let's suppose to change the center distance between the leads to 50.00 mm and the number of leads to 6. It's possible to change the value set for the technical data which however do not affect the model, such as for example the max pressurized, by setting it to 12 in the example, possibly based on the values read from the product datasheet. You can easily edit other properties, apart from those already present, by clicking on the Properties field, then on the button with the 3 dots. Edit mode is then enabled for insertion together with the management of new object properties. Once the configuration is complete, click on the End button and the model is then created in the project library, making it available for use within the drawing. Unlike other MEP objects, such as pipes, ducts, etc. For parametric MEP objects, you can't associate the type of system, acting from the Systems section in the toolbox on the right. In this case, in fact, the name field is set to automatic, as the entity will acquire the plant from the object to which it will be connected. In the Characteristics section, in correspondence with the Model field, the tooltip with the title of the object appears, consisting of the name of the chosen type, cast monoblock coplanar manifold dash, the parameter that determines the model and any other parameters, such as, for example, the number of leads and the path of the folder in the project library in which it was created. The anchor field allows you to choose the position of the object grip, both before and after generating the object on the drawing. By clicking on this field and from here on the button with the 3 dots, a model preview appears in 3D space, to which red cubes are associated in correspondence with the connection ports. The anchor field is an alternative to the F5, F6 keys, as well as to the release the object grip and its manual positioning, with the advantage of choosing the position of the object grip on the connection port. This field is very useful when the object has numerous connections and allows you to speed up insertion and connection with other objects. The selected red cube, in correspondence with which the object grip will be anchored, is highlighted in yellow and, after confirming with the green check flag, the object can be inserted on the drawing with the settings enabled. When the MEP object configuration is finished, it's automatically copied to the project library, even if its relating model isn't generated on the drawing. By clicking on the button with the 3 dots from the model field and thus accessing the project library, the configured object appears here, in addition to any MEP objects previously created in the same folder, which remain in memory regardless of whether they are shown or not on the drawing. Working on the drawing, with the first click in any point the model is generated, with a second click the object is positioned on a point of the drawing, making use of the object grip support. By selecting the object, all the labels of the connectors and the classic object grip of the BIM objects appear, which allows you to make rigid movements and rotations in the work environment. The toolbox on the right shows all the properties of the selected object. In the MEP System section you'll now be able to click on the connector field, select the connection from the menu and read in the following fields the system that it may have inherited from another MEP object to which it has been linked. Based on the selected connection, the connectors subsection is contextualized, which shows the type and connection external dimensions, etc. The geometry section shows the geometric parameters that define the model. The technical parameters are shown in the technical data section, possibly even if customized in the Parametric Configurator. In this case, the value of the max pressurized, which was set equal to 12.00. Creating a new MEP object by importing 3D models. The second option, available for creating a new MEP object, is to import the 3D model from an external file. Simply select the type of accessory, equipment or generic MEP object to be modeled from the drawing menu. From the Related Properties toolbox in the Model field, click on the first button and choose the option Create a new MEP object by importing a 3D model from file. The process of importing and generating the model is structured in 4 phases. The first step is to select a 3D model file to import. As specified in the caption that appears on the screen, the file chosen for import can be in any format. By clicking on the Browse button, you can reach the location of the file you want to import, select it and then open it. Another window appears, identified as the Import 3D model. Here you will be able to have a complete view of the object you are importing. An object perspective view is available, which can be orbited with the right mouse button and accompanied by 2 orthogonal lines, a green one to identify the y-axis and a red one for the x-axis. A red sphere identifies the intersection between these 2 axes and will correspond with the insertion point of the object on the drawing. 3 smaller views, placed side by side respectively, show the front view, the top view and the right side view. The options and position sections are available on the right side of this window. The first allows the management of general data, such as the name to be attributed to the object, and the setting of the object dimensions, length, width, height, whose values are automatically recognized by the representation of the object on the file being importing. However, it's possible to intervene on these dimensions, modifying them, and, if necessary, checking the Keep Ratio option, readjusting the other dimensions following the modification of one of them. The Reset button allows you to restore the data acquired by default from the model. From the Positioning section, it's also possible to manage the rotation and the insertion point of the object. For rotation, the choice between Rotate 90 degrees and Free Rotation is also available. The arrow buttons below allow object rotation in space, according to the choice made between free rotation, therefore without taking into account the axes, or vice versa, 90 degrees around each of the two axes, based on the movement specified using the arrows. The model is therefore repositioned in all views, and when confirmed, it will then match its representation when added to the drawing. From the last insertion point section, the positioning management for the axis X is available. In this case, using the arrows, directed according to the possible movements of each of the three axes, it's possible to move the axes around the various snap nodes identified on the model. As also specified by the caption below, this repositioning can also be done directly by moving the axis lines on the views. At the end of all these settings, click on OK and go to the next step. In the second phase, you will have the possibility to first select a category and then a specific type that is similar to that of the object being inserted. The categories and therefore the types proposed are those available in the library for the entity that was previously selected in the drawing menu. For example, the category Combustion Generators and the Floor Standing Boiler with the display are chosen. This choice is confirmed by moving to step 3/4. The third phase allows you to manage the characteristic data of the object. Also in this view, the 3D preview of the orbiting object is available. Following the category and type chosen for the identification of the object, you can manage different parameters for the entity, divided into object type and object properties. However, changing these parameters will not affect the graphical representation of the object. The last phase is dedicated to the modeling of the connectors, then to their insertion and/or their modification. Initially, the side toolbox of this window contains the fields title, description, brand, model, standard, which can be edited. By clicking on the Add Connector button, you can add a new connector on the object and, from the side toolbox, now containing information about the connector, you can manage its properties, typical of a connector object. By clicking on the Finish button, the object imported from the file and modeled is available to be inserted on the drawing, both in 3D and possibly on a level. In the Properties toolbox, related to the added element, you can find all the necessary parameters and settings assigned to the object during the modeling phase. Creating a new MEP object by converting an architectural 3D model. The last of the three options available as a way to generate an MEP object, when selecting the plus button in the model field, is represented by a magic wand icon and is named Create a new MEP object by converting a 3D architectural model. This feature allows you to locate a 3D model on the architectural in order to create a new MEP object on the basis of the acquired model, as in the case of a sink, a hob, a shower box, etc. Let's suppose you want to create an MEP object by converting the 3D model representing a shower enclosure. From the Design menu you can choose the Sanitary Water Terminal from the Equipment and Terminals row in the Mechanical Systems group. When the conversion option is selected, the wizard window appears, structured in 4 consecutive steps, with the possibility, from time to time, to retrace the previous steps in order to modify any previously confirmed settings. At the first step, you need to select the magic wand icon. We can then access the model view where you can recognize any 3D models available to be converted, as they appear colored in yellow. Moreover, passing over with the mouse cursor, you'll see that they will turn red instead, to specify compatibility with the conversion to be carried out. By clicking with the mouse on one of these blocks, in the specific case of the shower box, it's selected for conversion and the second step of the guided creation is now ready. In this second phase, it will be necessary to select the category and type of identification of an object similar to the one being created. The categories and therefore the types proposed are those available in the library for the entity that was previously selected in the drawing menu. By choosing the category and type, we can now proceed to the next step. In the third step, the characteristic data of the object are defined. The orbital preview of the 3D model just acquired appears in this window. On the right, there are the object type and object properties sections for managing the parameters to be assigned to the new entity being generated, which can be configured based on the category and type assigned to the object. By advancing to the next step, the last one, you can insert and/or modify the connectors. First, the user customizable properties are managed: title, description, brand, model, and standard. By clicking on the Add Connector button, you can configure the connectors directly on the MEP entity being modeled as needed, which will then allow them to be connected within the project. The connectors configuration, in this phase, is completely similar to the working mode seen in the connector editor, so they can be positioned at specific points on the object and they can be assigned with a shape, possibly a type of connector and a profile type, as well as others geometric and informative parameters too. Once the configuration is complete, you'll be able to see that the 3D model initially selected for conversion has been converted to an MEP object, with all the required settings and positioned exactly in correspondence with the starting 3D model. At this point it will be a MEP object in all respects, like other entities made available by the program. Therefore, once inserted on the model, if selected, the Related Properties toolbox will show all the parameters and data that characterize it. For the fields that provide for this possibility, changes can be made to then proceed to generating any links with other entities. The MEP object obtained is therefore characterized by a graphic profile acquired from its representation in the architectural environment and modeling parameters, which now make it configurable in the MEP environment, specific to the type of entity that has been assigned to it. The new element is added to the library in the 3D Models section. From the navigator, if you explode the Bim Objects Library's node to access the project library, you will notice that the 3D Models archive has been updated with the new configured entity which has been added. Its profile in the library contains images that represent the top view of the element, its 2D block in plan and the main view of the 3D model. In addition, its information and characteristics are included in the Object Properties toolbox, some of which can be modified. For example, by clicking on the button with the 3 dots in the Edit Model field, it's possible to change the size of the object and its positioning on the drawing. From the Materials section, on the other hand, it's possible to associate a different material to the various parts making up the model. For the shower box, for example, among others, there are the shower tray and the glass panels. From the button with the 3 dots corresponding to each field, you can access the Bim Objects Library to set the exterior aspect, therefore materials, and color for the specific selected part. Once finished with these changes, the entity already arranged on the model will be readjusted according to any new settings provided.